That's good enough. Dr. Sada, what are you doing here?
Afraid I got some bad news, Johnny.
What is it? Give it to me straight, Doc.
Your terminal.
Oh no! I'm terminal! How long do I got?
No, you idiot. Your solder on your terminal is abominable. I don't like saying it either, probably because it's so hard. Your terminal is abominable. Hey, I did it again.
Oh no! I feel terrible about this.
That's okay. I know a good remedy.
What? I'll try anything.
Well, sit up straight, stop your moping, and watch this. Somebody, get the popcorn.
This video will demonstrate the techniques for hand soldering wires to a variety of terminals. For our discussion, a terminal is a metallic connection device that is used to terminate a discrete wire or wires. The terminal provides both a mechanical and an electrical connection. There are several different types of terminals, each requiring specific hand soldering techniques. We'll be examining turret terminals, cup terminals, bifurcated terminals, hook terminals, and pierced terminals. For an overview of the tools and materials required for basic hand soldering of through-hole components to printed circuit boards, as well as safety and handling considerations, refer to IPC Video's DVD 42C for tin lead soldering and DVD 43C for lead-free soldering. A hand soldering iron with interchangeable tips will be used for soldering terminals. There are conical tips and chisel tips. Conical tips are round and chisel tips are flat. We'll be using chisel tips because they have a flat edge. A chisel tip with a flat surface has a much greater contact area than a conical tip and therefore transfers heat more efficiently. The first step is to tin the tip of the iron. Tinning will reduce the formation of oxides on the soldering iron tip. Oxidation acts as a barrier or an insulator, meaning it slows down the transfer of heat. It may also prevent wetting of the surfaces with fresh solder. Tinning the tip with solder also results in faster heat transfer. The insulated wire also needs to be stripped and tinned prior to attachment to the terminal. There are many ways to strip the insulated wire. Some methods are unacceptable because of possible damage to the insulation and the wire. The safest method uses the thermal stripper, which melts or softens the insulation. Use your fingers to twist the insulation slug off in the direction of the wire lay. Do not use the stripper to pull off the insulation slug, as it can potentially damage the wire. The main disadvantage of thermal strippers is that some insulation, such as PVC, will burn and release hazardous gases when melted. If you are not sure which types of insulation are appropriate for thermal stripping, be sure to ask your supervisor. The stripped wire now needs to be tinned. The purpose of tinning is to avoid damage to the individual strands when the wire is bent, and to improve solderability. To tin the wire, you can move it across a solder-coated iron tip, move a tinned tip over a stationary wire, or dip it in a solder pot. Before we begin soldering terminals, it's important to clean the soldering iron tip. This can be done by wiping the tip on a slightly damp, sulfur-free sponge, or dabbing it on a brass pad made specifically for hand soldering. We'll start with the turret terminal. The tinned end of the wire is first formed into a loop, since the wire will need to be wrapped around the terminal. The loop is then cut to fit the terminal. The wire end should not extend off the base of the terminal by more than 1 lead diameter. When forming the wire, you should use a tool that does not leave marks or impressions on the conductor, such as round-nose pliers. The loop you make with the wire should curve like a semicircle. An angled loop is not acceptable. Now the wire can be placed in position on the turret terminal. You know you have made a good loop when it snaps into place and wants to stay on the terminal even without any solder. There can be different degrees of termination of the wire wraps. For example, 180 degrees is halfway around the terminal, and 360 degrees is all the way around, or one complete turn. Your acceptance requirements may be based on your company's specification or IPC standards. For example, IPC A610 specifies that a wire diameter of 28 AWG or larger, built to Class 3 requirements, should wrap 180 to 360 degrees. A 30 AWG wire diameter or smaller, built to Class 3, should be wrapped more than one complete turn. During the soldering process, nothing, except for the technician's hands, should move. This will eliminate the risk of disturbed solder. The terminal should be mounted securely, and the non-soldered wire end should be held by a third-hand tool or equivalent. In the case of our turret terminal, if one wire is to be connected, it should be placed on the lower section of the terminal. It should lay flat against the base so that any mechanical stress will be transferred to the board rather than tilting the terminal and perhaps damaging the land. Another benefit of mounting the wire on the base is that the wire actually ends up against a corner between the base and the post. After creating top and bottom solder fillets, there will be a very strong mechanical connection. The turret manufacturers loved this idea so much, they gave you 2 bases to work with. With 2 wires, they should both be brought in from the same side so that the insulations touch. This will leave a gap between the stripped areas of the wires. The gap makes it easier to inspect the solder joint and allows for the 2 parallel wires to be joined with tie wraps or lacing. Now let's take a look at the proper technique for soldering turret terminals. The soldering operation consists of 4 basic steps. In step 1, the solder wire is placed in contact with the wrapped wire and the terminal. This is the point of greatest thermal mass and is called the contact point. This contact point will help to transfer the heat to both the wire and the terminal simultaneously. The soldering iron tip is brought into the contact point, melting the solder wire, thus forming a solder heat bridge. The purpose of the solder heat bridge is to transfer heat more rapidly to the solder fillet area and to preheat the wire and terminal so they are hot enough to melt the solder. During step 2, additional solder is applied on the opposite side of the contact point to form the necessary solder fillet. You will know you made a good heat bridge if the solder melts rapidly when it contacts the wire or the terminal. In step 3, the solder wire is removed. In the final step, the iron is withdrawn at the same angle it was introduced into the joint. Notice that the iron was inserted at one location, held still to transfer maximum heat, and then removed. The iron should not be moved up and down, making multiple contacts. It's appropriate to think of the soldering iron as a heat source, not a paintbrush. Let's watch the entire operation once again in real time. Another method of forming a solder heat bridge is to first place the soldering iron tip in contact with the wire and the terminal, and then add a small amount of solder to the contact point. Again, additional solder is applied on the opposite side of the contact point to form the necessary solder fillet. At this point, we'll remove the flux to inspect the joint. The cleaning requirements are the same as any other hand solder connections on a circuit board. Some companies use low residue or no clean fluxes, which may not require cleaning. Other fluxes can cause corrosion or contribute to dendritic growth. These residues will need to be cleaned off. It is important to adhere to the manufacturer's specification for solder temperature and cleaning requirements. Your company will supply you with a compatible cleaning solvent and instructions for its use. They will make the decision whether to clean or not based on customer requirements for reliability or cosmetic quality. Once the flux is cleaned, we're ready to inspect the solder joint. Do you know how to determine the correct amount of solder? What exactly do you look for when examining a solder joint? IPC A610, J-Standard 001, and IPC A620 all provide acceptance criteria for soldering terminals. Check that the solder is feathered out smoothly, showing good wetting action over the wire and the terminal. Wetting is the adhesion of a smooth, unbroken film of solder onto a base metal. The outline of the wire should be visible under a thin film of solder. This connection location is called a fillet. On a proper solder joint, the solder fillet is slightly concave or curved inward. A concave fillet that tapers to a feathered edge not only looks good, but also reassures us that the solder bonded to the two surfaces we were trying to join. When there is insufficient solder, the joint may not have acceptable mechanical strength. When there is excessive solder, the fillet will be convex and the outline of the wire will be buried in the mound of solder. This is undesirable because the excess solder can hide defects in the connection. It is important to solder so that the joint can be visually inspected. Soldering for inspectability means you're always able to see the outline of the wire in the joint. When excess solder is evident, the outline of the wire will not be visible. The next type of terminal we'll discuss is the cup terminal. The cup part is a hollow cylinder. The wire will be inserted into the cup and then soldered. During any soldering process, nothing except the technician's hands should move. This will eliminate the risk of disturbed solder. The terminal needs to be mounted securely, and the non-soldered wire end should be held by a third-hand tool or equivalent. The wire size must be matched to the terminal. Never modify the wire or the terminal to make the wire fit. Several smaller wires may be placed into a single cup, as long as the wires do not exceed the diameter of the cup. It is not acceptable to twist multiple wires together before inserting them. The twisted wires may trap flux inside and may also change the acceptable diameter of the wires that are inserted. Now let's examine the steps to properly solder wires in cup terminals. First, insert the pre-tinned wire into the cup to measure for correct wire length and insulation clearance. For minimum insulation clearance, the insulation may contact the top of the cup, but not interfere with the solder wetting to the inside of the cup terminal. Maximum insulation clearance should be less than 2 wire insulation